All right. So, Passport to Advanced Math, Lesson 5 is all about factoring and kind of leading towards solving quadratics. So, this is standard 1 and 11 where we're creating a quadratic or exponential function or equation that models the context. And then 11, this lesson is more geared towards understanding the relationship between factors of polynomials. Okay. Now, first, what's a quadratic expression? Well, this is any mathematical expression whose power or degree is 2. So basically, if we have x squared plus bx plus c, where b and c are numbers. So the highest exponent in the expression and later on in the equation is 2. Now, when we factor quadratic equations or expressions, we're basically rewriting a quadratic expression as a product of two binomials. So there are three common ones we deal with. One is when we have when we factor with a leading coefficient equal to 1, meaning there's no number in front of x squared. When we do this, we find a number that multiplies to give us the constant and adds up to the middle term. So in this case, what multiplies to give us 8 and adds up to -6? So right away, you know -4 times -2 would multiply to give you 8, and then -4 plus -2 would also add up to -6, so this would factor out to be x minus 4 times x minus 2. Now, a difference of two squares. Anytime you're asked to factor and you're given a difference of two squares, you would have two terms linked by subtraction, and both are perfect squares. What's the square root of x squared? X. What's the square root of 16? 4. So you know right away that this would factor to add the perfect squares and subtract the perfect squares. One less common one that you guys have used throughout high school is a perfect square trinomial. And this should be 12x, or 12a, sorry. Okay, when I look at this, anytime I get something on the SAT that has a number in front of the x squared, or in this case, a squared term, they don't have a lot of what we referred to back in the day as AC method. It could be, but what I would always check for first is, can I take the square root of the first and last term? Is this a perfect square? Yes. Is this a perfect square? Yes. So right away, I know that this would be 2a plus 3 all squared. 9 times out of 10, anything that has the first term is a perfect square and the last, it would work out this way. Okay, so let's take a look at what we have here. The first problem, it says, which of the following is a factor of the polynomial x squared plus 3x minus 18? That's very similar to the first question we did. What multiplies to give you -18 and adds up to 3? That would be 6 times -3 would give me -18. 6 plus -3 would be 3. And now this would factor out to x plus 6 times x minus 3. And which one of these is a factor? No, 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 and yes. All right, the next one. If r and s are constants, x squared plus rx plus 12 is equivalent to x plus 3 times x plus s. What is the following value of r? Well, x squared plus rx plus 12 equals x plus 3 times x plus s. And they want to know what the value of r would have to be. Well, think about it. Can we figure out what s would be? Well, we know the first two terms, x times x, right? These multiply to give us that. And the last terms have to multiply to give us this. So 3 times what, right, would give me 12. Well, you know s has to be 4. And now when I look at it, the middle term, x squared plus 4x plus 3x. 3 times 4 is plus 12. This is what I need right here. That would be 7x. So you know r would equal 7. Letter H. Okay. Now the next one. It seems like after looking at all the tests, a difference of 2 squares is very common in SAT. Now, they're saying if u plus t equals 5, u minus t equals 2, what is the value of this expression? This is a gridded response and no calculator. So, right away, we know u minus t could technically down the road be replaced with 2. But u squared minus t squared, we don't know the values of any of that. But I do notice that this here is a difference of 2 squares. So right away, when I go to factor u squared minus t squared, I'm going to take the square root of both, which is u and t, and then that will factor out to be u plus t times u minus t. So now this expression translates to u minus t times u plus t times u minus t. Now I can replace u plus t, u minus t with 2 times u plus t can be replaced with 5, and then u minus t can be replaced with 2, and 2 times 5 times 2 would give me 20. So this gridded response, you would bubble in 2, 0. The next one. Most kids will get this wrong, and we need to make sure we hammer this on the test. In the equation above, a is a positive constant, and the graph of the equation in the xy plane is a parabola. So you know this is a quadratic. Which of the following is an equivalent form of the equation? Well, here's the thing. What they're basically trying to do to write the equivalent forms in all of the answers is factor this. Well, that happens to be, right, 2 terms linked by subtraction. They're not both perfect squares, but when I look at my answer choices, they factor it as a perfect square trinomial or a difference of 2 squares. Well, let's look at this. If I were to take the square root of both of these, this would become y equals the square root of x squared is x, the square root of a is just the square root of a. And if we write that as a difference of 2 squares, x plus the square root of a times x minus the square root of a. Is that an answer choice down here? Yes, letter B. Okay, so that's a tough problem, but it's one after being exposed to it, you should be able to get. The last one here, if a squared plus b squared equals z and a times b equals y, which of the following is equivalent to 4z plus 8y? What I'm going to do is plug a squared plus b squared in for z here and ab in for y here. Now, that would give me 4 times a squared plus b squared plus 8 times ab. If I distribute and then I simplify this, I would get 4a squared plus 4b squared plus 8ab. Now, I'm going to rewrite this with 8ab in the middle, so that's 4a squared plus 8ab plus 4b squared. Now, if you look at my answer choices, right, none of them look like what I just got. There are 2 ways to go about this. One, you could take all of these and just quickly FOIL them out. A times a is a squared. Right away, you know that's not going to match up, right? If I write this out as 2a plus 2b all squared, right? Oh, sorry. 2a plus 2b times 2a plus 2b, right? 2a times 2a is 4a squared, right? That matches up. 2b times 2b is 4b squared. And now 2a times 2b is 4AB. 2b times 2a is 4ab. That's going to give you 8ab. So when you FOIL this out, it matches up with that. So it would be letter B. The other way is to recognize what I said earlier. If you can take the square root of the first term and the last term, that would be 2a, that would be 2b. It's most likely going to be a perfect square trinomial, and it's just this and this with this sign in the middle, which is letter B. All right, so go ahead, try the mini quiz, and let us know if you have questions.